Good morning, everyone. I'm Ollie Lancaster, IGEM Chief Executive, and it's my great pleasure to welcome you to the 20th IGEM Young Persons Paper Competition Final. This is different from the scenario we envisaged for such a prestigious event. And while it is a great shame we're not able to meet face to face and see our amazing finalists up on stage in front of a large audience, I'm delighted that the event is going ahead online, and I'm sure it'll still be every bit as enjoyable. IGEM is keen to give young people working in the gas industry opportunities to enhance their career prospects. Every year, the YPN organises this competition that encourages and rewards entries from young professionals who can show that they have the potential to make a valuable and meaningful contribution to the industry. I've personally been looking forward to this since I started with IGEM at the end of the summer. I know that I look older than I am, but it really doesn't seem all that long ago that I was participating in this process myself, and I definitely benefited from it. I'm just excited to hear, as I'm sure you are, about the work that our young people have been leading on and pursuing for their own development, their organisation, and the sector as a whole. Young people are going to be developing and delivering the future for the sector and have a significant influence on how energy will be delivered for industry, home and commercial heating, transport applications, and power generation. It was about 8 or 9 years ago that I remember biomethane being the cutting edge, with a few finalists presenting on the topic, and that is now business as usual. Hydrogen is taking, quite rightly, some of the limelight at the moment, but it's not all about net zero. And don't get me wrong, net zero is a huge part of our industry's activity at the moment and is the biggest show in town. But we have the job of today, dominated by natural gas, to be getting on with to engineer and manage our way through the energy transformation. So it's great to see such a rich collection of subjects being presented in this first session, covering the integrated energy system, compressors, indoor air quality, the future of gas cooking, distribution asset management, and the extension of the gas network. What a great mix. Just to remind you that we are recording this event and it will be available to view on IGEM TV afterwards. I'll now just like to pass you over to the YPN chair, George Brookfield, to introduce the speakers and chair the session. George, over to you.
Thanks, Ollie, and good morning, everybody. Thank you all for joining us this morning. It's great to have all the contestants on and so many people here to celebrate their achievements and their work and hear about what some of the stuff they've been up to. So to take you through the session, only one of our stellar contestants can be crowned the winner, taking home a ticket to once in a lifetime trip to the World Gas Conference in 2022 in Korea, and have their name engraved on the prestigious IGEM YPPC trophy. Our finalists each have 15 minutes to present and then 5 minutes to answer any questions from the judges. If you have any questions for yourself, for any of them, please submit them into the chat facility and they will be answered hopefully in the chat. And if we have time within the 5 minutes, I'll get to them and pose them to the finalists. In this first session, we'll be listening to the first 5. We'll then go for a short break, grab a cup of coffee, and then we'll be back in time for the following 5. Then we'll be followed up with another break as the judges make their crucial decision, and we'll be coming back for the final a little later, just this afternoon. But first, before we get into the finalists, I'd like to introduce our judges for the day. So we have our head judge of the judging panel, which is Ben Clark, Technical Director at WSP, and our IGEM President and also past winner of the YPPC. He's joined by Andy McPhee, Chair of IGEM's Professional Development Committee, and Lucy Ritchie, Senior Client Manager, Energy at Energy and Utility Skills. So without further ado, I'd like to introduce you to our first finalist, Chi-Kun Chen, PhD student at Cardiff University and the Wealth Section Heat winner. The title of Chi-Kun's presentation is Optimal Operation of Compressors in an Integrated Gas and Electricity System. Chi-Kun, over to you. You've got 15 minutes.
Okay, can you hear me, George?
Yes, yeah.
Okay, thank you very much. Let me just share my slide. Actually, there is a little change before. Sorry, but I can hear some noise. Okay, there is a little change of my title of presentation. It is now the coordinating operation of compressor unit in GB gas transmission system. Let me just. Good morning, everyone. I'm Chikun Chen, a PhD student from Cardiff University. So honored to be here talking about my current research work, which is related to the gas industry. Today, I will give a presentation about coordinating operation of compressor unit in GB gas transmission system. Let me briefly introduce myself at the beginning. Before coming to the UK, I've been studying in Southwest Petroleum University in China for 3 years as a master's student. And in this period, my research work is mainly on analyzing flow field, for example, like a multiple flow or turbulence flow in gas infrastructures based on computational fluid dynamics. Then 1 year ago, I came to the UK to attend my PhD in Cardiff University, and now I'm mainly focused on modeling and optimization of the gas network, with the purpose to clarify the future role of the gas network in adapting increasing penetration of renewables. So what I'm going to talk today is the compression system in the GB gas network, and I hope this presentation can provide a better understanding on the role and benefits of these compressors. This is the outline of my presentation. In the background section, I will explain why we choose the operation of compressor units as the topic today and what is our purpose. Secondly, I will talk about what is the coordinating operation of compressors and how can we find an optimal way to operate them. The approaches we employed, including the numerical modeling and optimization, will be briefly introduced in the third section. Finally, I will highlight some benefits we can obtain from these compressors while discussing the results from our modeling. So first of all, let's have a glance on today's gas in the UK. According to the report published by the National Grid, there are almost 22 million of gas consumers across the UK, and 85% households are using gas for heat, and nearly 900 terawatt-hour of energy is satisfied by gas annually, which means that gas plays a very important role in the UK. The national transmission system of gas is employed to transport gas from the terminals to the offtake point. Due to the gas is easier to be stored and more dispatchable, so not only delivering energy, but also the gas network enhances reliability of power grid via gas-fired generation. The compressor units are very important in operating the gas network. They are installed along the gas pipelines to boost the pressure of the system, as the pressure inside will be decreased with gas flowing through the pipe due to the energy loss. More importantly, compressors can be used to maintain the level of line pack as it can control the pressure. The compressor station is very important to the gas network though, due to the operation of them result in emissions of several air pollutants such as nitrogen oxide, as shown in the figure on the left-hand side. The emissions from fuel combustion in driving compressors at different sites is more than 500 tons per year. Not only the air pollutant, but also the compressors will emit greenhouse gas such as carbon dioxide. To make them more friendly to the environment, emissions from this compressor unit is required to decrease according to the Industrial Emissions Directive. But what can we do to reduce emission? New technologies on electric motor is powerful to driving the compressors as well. And now several electric driving compressors are into use in the GB gas network. As of 2019, the max capacity of these compressors are almost 200 megawatts. So here you may ask, why not replace all the gas-driven compressors by electric-driven compressors? This is because the electricity price is fluctuating due to a day and can be very high at some time period, as the figure 3 shows. So using only electric-driven compressors, they can increase operational cost. Besides, the capital cost can be high, which should also be taken into account as well. So at this stage, we hope we can find the optimal operation of compressor units that can reduce emissions and save cost as well. But how can we achieve this? We can use line pack as a lever. When energy price is lower, we can increasingly use the compressor units to increase the level of line pack and hence raise the pressure as well. And when energy price is higher, the compressor unit is not required to work hard as the pressure has already been increased. Moreover, we hope the gas-driven compressors will be employed and electric-driven compressors are not working when the gas price is lower. Otherwise, when electricity price is lower than that of gas, we hope electric-driven compressors can be employed. To achieve this point, here we propose a novel system for operational of the compressors. This is the simplified control system of the hybrid compressor station. There are two decisions will be made in different processes by the system. The first decision is whether to turn on the compressor unit or not. If the compressor is not required, then the valve 1 will be opened, valve 2 and 3 will be closed, which means that the gas will only be allowed to flow the bypass line. And under this condition, the compressor is in off status. Otherwise, the compressor is used and valve 1 will be closed. And then the second decision will be made, determined by the relative price of gas and electricity. If the gas price is lower than that of electricity price, the valve 3 will be opened while valve 2 will be closed. And this time, gas-driven compressors will be used. Otherwise, the electric-driven compressor will be used. Based on this is an overview of our methodology. With considering the coordination operation of compressor units, we formulate our problem via modeling and optimization. The objective function is the operational cost of the gas network, including cost for satisfying gas demand and cost of energy consumed by compressors. And then we use the real data, for example, the day-ahead energy price, parameter of pipelines, operating parameter of compressors, and gas demand data. And based on this, we then numerically modeled the gas network, including the hydraulic modeling and compressor modeling. And then some of technicals are used, including the long convex optimization and mixed integer second order column programming are used to solve the problem. And our aim is to find the optimal operation of compressor units with minimum cost and lower emissions. Due to the large scale of the gas network is very complex in computational modeling, so we made a reasonable simplification, which remains the same number of compressor units and gas terminals are shown in figure 4. And the simplified gas network comprises 76 pipelines, 68 loads, and 24 compressor stations. The gas demand day-ahead energy is shown in the figure 5. To highlight the benefit of the hybrid compressor station, we defined 3 scenarios here. Scenario 1 is under the current distribution of compressor units in GB gas network, which is 7 hybrid compressor stations and 17 gas-driven compressor stations. Scenario 2 is a case that we only use electric-driven compressor units in GB gas network to achieve 0 emissions. Scenario 3 is a case that all compressor stations in GB gas network is hybrid. And after running the model, we got some very interesting results. From the figure 5, it can be found that when gas price is lower and the gas-driven compressors are employed, as the purple column highlighted in the red circles. And when electricity price is lower, the electric-driven compressors will be employed as highlighted in the blue circle. But unfortunately, due to the lack of gas-driven compressors in coordination, the electric-driven compressors have to work even the electricity price is very high. And the operational cost of compressor units in each scenario is compared. And I think all you can get the result using hybrid compressor stations most cost-effective, as it only costs around 24,000 pounds per day and only generates a half carbon dioxide emissions compared with that in scenario 1. Although there is no emissions produced in scenario 2, but the operational cost is very high, at more than 44,000 per day. Moreover, the flexibility of the compressor units in each scenario is quantified. Before we discuss this, let me just explain what the flexibility here we talk about is. It is referred to the ability of a system to adapt dynamic and changing conditions. As electric-driven compressors consume electricity, so their operational regulation will affect the flexibility of power grid. And we can consider the more a compressor unit can be regulated within their capacity, the more flexibility it can provide. And the ability of compressor units to adjust their operation in each scenario is shown in figure 6. The blue arrow between the maximum operation and the scheduled operation of a compressor unit is upward regulation, and the green arrow between the scheduled operation and minimum operation is a downward regulation. The changing range of the operational regulation indicates the level of the flexibility of the compressor units. So as can be observed, the regulation range of compressor units in scenario 3 is widest, as it can fluctuate from 0 to 420 megawatts, which is almost twice than that in scenario 1. However, in scenario 2, even the upward regulation of these compressors can be high up to 300 megawatts. The downward regulation of them is very limited, as there is no support from coordination of gas-driven compressors. So we believe using hybrid compressor station in GB gas network can provide more flexibility. And here we got our conclusion. The hybrid compressor station is more cost-effective in operation, and using hybrid compressor station is helpful in providing more flexibility to power grid. So based on this, our future work is the potential of the gas network in path to net zero, for example, the hydrogen and transportation, and optimal operation of compressor units in the integrated gas and electricity network, and also including the adaptation of compressor units to uncertainties in operating the gas network. So that's all from me, and I'm happy to answer any questions if you have.
Thank you very much, Ji-kun. I'd like to invite the judges to share their videos and come off mute and provide any questions they may have for you. Good presentation. Thank you.
Thank you.
I'll go first then. Firstly, thank you very much for the presentation. Very much enjoyed it. Different area for me personally. Just to kind of get us going. The first question for you is, you've talked through the development, and there was very clear logic throughout. What didn't come across to me in the presentation, I would appreciate if you could explain a little bit more, is what's your own personal involvement been? Which aspects of the modelling has this been all you? Have you been part of a team? If you could just give us a little bit more insight into that, that'd be much appreciated. Thank you.
Okay, so at the start, this idea is born from my supervisor, because many of you may, when we talk about the compressor unit, many of you may consider it can just be used to increase the pressure, or but nobody can think about the compressor can be used in different time periods. For example, like to increase the line path, which can be dispatched in different times to compensate the gap between the gas demand and gas supply. And moreover, it can be used like a buffer to save cost from the operation of compressor units. And from me, I modeling the gas network and some technical points like optimization and numerical modeling is conducted by me. And our aim is to find the optimal operation of compressor units, for example, how to save cost and how to reduce emissions from this compressor unit.
Andy or Lucy, would you like to go next?
Can I question again? Compliments, Chicken, on the presentation. The concept of a hybrid compressor station is an interesting one. Is that at the moment theoretical, or have you looked at the comparability for duty of an electric and gas compressor in the sort of range of flow conditions it might that might pertain at, say, a large capacity compressor station compared with a smaller one elsewhere in the system?
At this stage, we have set the capacity of each type of compressors in our optimization modeling. For example, the 35 megawatt hour or 50 megawatt hour, we can set it by ourselves automatically. But on the other hand, we do not go into the real gas industry to look out how these compressors are functioning. But what we have now is we know the compressor unit in GB gas network is parallel configured to operate, and we try our best to make our model as real as the practical one.
Okay, thank you.
Thank you very much.
I think we've got time for a quick one from me. Thanks for the presentation. What specific challenges have you faced? I guess throughout COVID and the pandemic, has that presented you with any sort of specific challenges?
Sorry, could you please
repeat the question?
Yes.
I was just wondering whether you'd experienced any sort of specific challenges that you faced, and whether you've made any mistakes, and would you do anything differently? And as COVID, for instance, impacted the work that you've done?
Yes, at this stage, it is tough for us because, you know, due to the COVID, and we just reduce face-to-face meetings as possible as we can. So sometimes it is also means that we lose some opportunities to cooperate with the gas industries in practical. And because due to of some lack of the data, and maybe we cannot model our, for example, the gas network or the compressor unit as well as we can, if we can get more data from the industries, and I think we can improve our model.
Thank you.
Yes, and just more words. And in our next stage, I think because due to the decarbonization target, and we think we can also consider the hydrogen to feed the compressor unit as well. And we also take account into the carbon price in our next stage to think about how can we make profit and reduce operational cost in these issues.
Thanks for that, Chico. I'll have to stop you there, but yeah, thank you, judges, for those questions. And yeah, well done, Chico, again on a good presentation. Thank you.
Thank you very much.
I would like to then move on to the next finalist. But quickly before I do, there was a couple of messages I received about being able to see Chicon's video or not. If finalists can just remember to share the video. I know, Chicon, you were, because I could see you, but if you just make sure you've got your settings so everybody can see your video, that'd be much appreciated. So Kyle, I can see you there waiting, so thank you. So yeah, Kyle Au is an engineer at the Hong Kong and China Gas Company Limited, and the first runner-up from the Far East District at Section Heat. Title, as you can see on the screen from Kyle's presentation, one of the best titles, which is Indoor Air Quality Enhancement by Advanced Town Gas Desiccant Humidification System with Utilization of Solar Energy in COVID-19 Age, which, as I said, I think is a fantastic title. So, Kyle, if you're ready, over to yourself.
Okay, just for a minute. So can you see my PowerPoint?
Yes. Yeah.
Okay.
Can do.
So yeah, I'm going to start. Hello everyone, I'm Kyle of the Hong Kong and China Gas Company Limited, and my YPPC topic is IAQ enhancement by advanced town gas desiccant demarcation system with utilization solar energy in COVID-19 age. Okay. Hong Kong's weather is hot and humid. According to the Hong Kong Weather Observatory, more than 300 days, the average RH is larger than 70% in 2020. And over 100 days, the average RH and temperature is larger than 70% and 28 degrees Celsius. The indication of fresh air is a common way to provide IAQ enhancement and thermal comfort. However, the passive humidity control by the conventional air conditioning system may result in overcooling the indoor environment and waste of energy. Here's a very typical example is the freezing indoor temperature in Hong Kong shopping mall during the hot and humid summer because of demarcation by air conditioning system. Town gas desiccant demarcation is a more energy-saving way for temperature and humidity control because it consumes less cooling energy. However, the traditional practice is require extra space to install a standalone desiccant dehumidifier with additional ductwork connection with the primary air handling unit, which is very difficult to install in Hong Kong because of space limitations. Another problem is the flue gas from the direct fire burner may enter to the airstream through the processed air because the dehumidifier is not 100% air sealed, which may raise the safety concern from client. My project is to provide a comprehensive solution for those problems and also to integrate it with new features in order to increase the competitiveness of demarcation by gas energy in the markets. My gas demarcation project is successfully implemented in H Center, which is located at Tsim Sha Tsui in Hong Kong. It is a redevelopment project, and the building is already operated in 2019. The main features of H Center is a combination of dining, wellness, and retail in one single complex. There are 10 numbers of the wellness floor at the middle of the buildings, and there are different kinds of medical centers or clinics are located there. Here are the objectives of the project requested by client. First one is to provide town gas provision for the dining floors. Second one is to provide IAQ enhancement on the 10 numbers of the wellness floor by gas demarcation, which can bring the excellent IAQ and thermal comfort to the occupants for medical treatment. And finally, is the sustainable achievement in order to secure the Green Building Assessment with the final platinum grade from the Hong Kong Green Building Council. As a representative of town gas, I've proposed and implement a compact solution for the gas riser installation and also the gas demarcation system, which can utilize solar energy to accomplish clients' objectives. My project is based on some literature review, especially for selecting the optimal range of indoor temperature and relative humidity, as result IAQ improvement and enhancement. ASHE provides the standard of the comfort zone, which means to control a specific range of temperature and relative humidity to maximize human comfort, and also inhibit the growth of mold or bacteria, which contribute better IAQ. A quantitative research by City University of Hong Kong has been concluded that without fresh air demarcations, it is very difficult to achieve the requirement of the comfort zone in Hong Kong. Further IAQ improvement can be achieved by fresh air sensitization, which also has been comprehensively studied by ASHE. Germicidal UV lamp could generate ultraviolet with 255 nanometer wavelength to inactivate the virus inside the airstream by damaging their DNAs. I also reference to the ultraviolet germicidal irradiation handbook to investigate the effectiveness of UVC to coronavirus in order to reduce the transmission of airborne virus and prevention of pandemic issues. To achieve space saving, I've coordinated with the contractors and manufacturers to to find a way to integrate the necessary component for the gas dehumidification into the primary air handling unit, including the desiccant wheel, the heat exchanger of the hot water for the hot water, and the germicidal UV lamp, so that we don't need extra space to install standalone desiccant dehumidifier. The function of the fresh air, the function of the fresh air dehumidification and also the fresh air synthesization is combined together, so that we call this product as integrated DPU, because there is a desiccant wheel inside the primary air handling unit. To avoid exhausted flue gas and the airstream and achieve building sustainability, the regeneration energy of the desiccant wheel was driven by the gas water heater and solar energy, so that it can reduce the energy consumption. After confirm with the consultant and client about the achievable target indoor temperature and also the relative humidity to deliver the best thermal comfort to the occupants, I started with the solar thermal panel sizing based on the rooftop area. 65 numbers of the solar panel is the maximum number of installation. Vacuum tube type panels was chosen to install because of high efficiency. Then I coordinated with the desiccant wheel supplier in order to find the suitable dimension and also the required hot water temperature for the desiccant wheel regeneration process. Then I can size the volume of the water storage tank based on the total output power of the solar thermal panels, and also the required hot water temperature of the desiccant wheel regeneration. 5 numbers of condensing instantaneous gas water heaters were installed to maintain the hot water temperature, even if the output power of the solar thermal panels is not enough. Also, the control logic is designed in order to operate the gas dehumidification system to precisely control the humidity and also the temperature. The gas dehumidification system is fully operated in June 2020. Total 65 numbers of the solar thermal panels are installed on the rooftop to absorb the solar heat. Then the heat will transfer to the water storage tank to heat up the water indirectly. The water heaters will turn on when the water output temperature is below 70 degrees. The hot water then transfers to the 10 numbers of the integrated DPU for the desiccant wheel regeneration only when the ambient relative humidity is equal or above 55%. If the ambient relative humidity is below 55%, the hot water circuit will bypass the integrated DPU and then go back to the water storage tank for reserving the hot water. The annual energy saving by the solar thermal panels is around 146,000 kWh, which already took the efficiency loss of the equipment. Here's the result of the on-site measurement. As you can see, the humidity of the wellness floor at X center is at the middle. It's constantly maintain the design condition, 55% average at 23.5 degrees Celsius, even though the ambient humidity is near 90% in this cloudy weather. This showing that the integrated DPU can effectively remove the air moisture and also achieve precise humidity control by using gas and solar energy. Compared to the conventional air conditioning dehumidification method, the gas dehumidification system could achieve 7% in cooling energy saving. The solar energy utilization brings another 5% energy saving for the desiccant wheel regeneration, so that the total energy saving is 12%, and the annual energy saving is around 357,000 kWh, according to the operation hour. The energy saving calculation is based on the psychometric chart and also the actual gas consumption for the desiccant wheel regeneration process. To conclude, the gas dehumidification has accomplished different environmental achievements. First is the energy saving compared to the conventional air conditioning dehumidification method. To improve the indoor air quality by precisely control the indoor temperature and humidity. Additional energy saving by the solar energy utilization. raise the standard of the fresh air treatment by installing the fresh air sanitization equipment. The total annual energy saving is around 357,000 kWh, which equivalent annual 195 tons reduction in CO2 emissions and annual 458,000 Hong Kong dollars in energy cost saving. In early this year, I have submitted and also present my project details to the Professional Engineering Association for participating project competition. I'm so proud that this project has received an international award, Innovative Energy Project of the Year, by the Association of the Energy Engineers, and also the project award from Institute of Mechanical Engineers. I also responsible to arrange technical visits and presentation in order to promote the benefits of gas deligation in the market and also in the industry. Finally, I thank you for the IGEM committee for selecting me as one of the YPPC finalists. Thank you very much.
Thank you for that, Kyle. It's absolutely fascinating to hear the extent of the, how the gas industry is, doing so much. I'd like to invite the judges again. I can see you've turned your videos on. Excellent. Any questions for Kyle, please?
I'll let Andy go first this time, and then I'll go last.
Okay. Thanks, Kyle. Impressive presentation and impressive project as well. You've covered a lot of ground in quite a short space of time. Can I just ask you a bit more about UV sterilisation? You're in two questions really. One, could you just say a little bit more about it? And secondly, there's a lot of good information on cost savings and benefits. What about is there any numerical information on the improvement to air quality, and particularly in the pandemic context?
Actually, this is a theoretical calculation which I referenced to the germicidal irradiation handbook. Actually, this is a calculation process I calculated by the actually, I didn't do a field test to test any what is the actual removal rate of the virus by the on-site measurement. I didn't do that, but I based on some calculation and research which the reason I installed the germicidal UV lamp to the client, because that can be a possible way to provide a solution for prevent the pandemic. Here's the calculation. I based on the specification of the UV lamp and also the nameplate of the PAU. I calculate the exposure time by the volume of the PAU, which divided by the airflow rate of the PAU. And then this is the constant, which based on this the handbook K, which is K is the constant. And then the mean irradiance is based on the UV lamp, the specification of the germicidal UV name. So that 1 minus the exponential by multiple this K, L and E, exposure time and constant, and the mean irradiance. I get it removal rate. So yes, this is that I calculate. That's my calculation.
Okay, thank you very much for a full answer. I'll pass over to Lucy.
2 minutes remaining for questions.
Thank you, Carl, and thanks for a fantastic presentation. Just a quick one from me, and congratulations on winning your award. Fantastic.
Thank
you. So you've handed over, you finished the project. Have you got any plans for sort of replicating that work or scaling up?
Actually, this is another. There's a few projects because for the solar panel case, it is very unique case. I can say, because for my case, is right. The building is quite high-rise building, but this actually is not much high-rise building, and also because the buildings in Hong Kong, there are many buildings blocked up by other high-rise buildings. So I can find a suitable plan or place to install the solar thermal panel. It's quite difficult, but there are fields case is disgusting. For example, some aircraft engineering storage place, because the rooftop of the storage plant is quite big, so I can install sufficient solar thermal panels on the rooftop. I also say because it's quite difficult because there's many commercial buildings on the rooftop is already occupied by the other E&M equipment, so it would be quite difficult to install the solar thermal panel on the rooftop in Hong Kong. But for the integrated DBU, actually, there are many
Sorry
cases.
to interrupt you, Kyle. Are you able to wrap up your answers to keep this within 5-minute Q&A?
Okay.
Thank you.
Okay. Thank you.
Oh, sorry, I didn't mean to
okay.
end you right there.
Okay.
Any final
Okay.
remarks?
Okay, because we have already successfully installed the integrated BU to another hospital and the hotels. I think it's more easy to promote the integrated DPU by integrating the desktop view into the PAU unit. So it's quite.
Kyle, I think I will have to cut you short now, unfortunately.
Okay.
Thank you very much.
Thank you.
Thank you, Kyle. Thank you.
Okay.
Ben, sorry, did you have any quick final questions you want me to slip in there, or should we progress?
What I'll do is I'll drop a question onto the chat function. I was going to ask a quick question about the cost of the project versus the savings and the payback period, but I'll drop it into the chat. So that's great. No problem, George.
Super. Thanks for that, Ben. Yeah, thank you, Kyle. That was enlightening and really informative. Thank you. I'll now like to move on to our third finalist, Dexter Hong. Dexter is an engineer at the Hong Kong and China Gas Company as well in the Far East District section, Heat Champion. Dexter's title presentation, as you can see on the screen, is the development of smart control devices for domestic cooking appliances. So Dexter, whenever you're ready, over to yourself.
Thank you very much. Can you see my presentation here?
Yes, can do.
Yeah, good morning everyone in the cameras. I'm Dexter Hong from Hong Kong China Gas, and today I'm going to share with you my project, which is the development of smart control device for domestic cooking appliances. So the government in Hong Kong has started launching the Smart City Blueprint 2.0, aiming to provide benefits to citizens with innovation and technologies. And we believe these strategies are also happening in other countries, as they are looking for products that can provide convenience to their residents, as well as a safe living environment. And talking about safe living environment, fire accidents is one of the concerns to home safety. And before moving on, I would like to show you a typical kitchen in Hong Kong, which you can see is a very limited space to put a hot plate on the table or built-in hub on the table. And because for the presentation, I tidy up the space, but in the actual environment, this kind of stuff is everywhere. So it's very to cause fire accidents if we put a flammable stuff like the oil and wine nearby the cooking appliances. And in Hong Kong, there are over 1,000 fire accidents related to stove every year. One of the causes is due to the busy housewife or busy urbanite. They're often unattended to their stove due to their forgetfulness. And especially talking about the elderly, a study found that they almost cook every week. And over half of them admitted that they have forgotten to turn the stove off at least once a week. So it's a very serious issue. Therefore, in Hong Kong, we have launched the Smart Kitchen development and launched the first smart hub that allows users to interact with the appliance using smartphone to perform safety functions like having the real-time status of the appliances and remote turning it off. Yet, we estimate that it will take more than 8 years for complete transition from the non-smart appliance to a smart one, because it will take time for all the users to start replacing their old stoves. So we are looking for a low-cost approach that allow us to fully utilize this smart kitchen system and upgrade the existing old stove to a smart one to perform safety functions to protect our users. That's why we come up with the idea to design a smart control device which consists of 3 main components. The first of all is a flow sensor, which is used to monitor the stove on-off status, followed up by a shut-off valve, which is used to control the gas applied to the stove, and lastly, a communication module that can interact with the users. And by retrofitting the device to the gas system, it can work with the existing stove to perform those smart safety features similar as a smart hub. And we believe it's a quick implementation for the smart kitchen development as well as a device that can ensure our home safety. But what are the criteria of selecting these components? And let's begin with the shut-off valve. So in the market, it's very easy to find some products like the solenoid valve and electric ball valve. Although their reliability has been proven, but their cost is relatively high, and in general, they have a high power consumption. And then I discovered the shut-off valve, which is used in the prepaid gas meter, and which is low cost, low power consumption because it's driven by gears and a very small motor, and it's also reliable to use. Therefore, I look for some more similar products, and luckily I found a one that's readily available. Its mechanism is similar to this valve, and the diaphragm is driven by the motors so that it pushes down and blocks the opening and shut the gas off. So it's very simple. So moving on, I also need to select a good sensor to detect the stove on and off status. And a good sensor should consider 3 features. First of all, it should be compact in size so that the total product size is small, that allow us to retrofit it into the limited space in Hong Kong kitchen. Also, it should be sensitive enough to suit for different flame levels. And even at the smallest flame, it should be able to give us a stove on indication. And finally, it should also be stable, as we know that it is always a common gas applied to all the gas appliances, and we do not want the sensor to be interfered by appliances other than the stove and mislead us. Therefore, during the sensor selection, I've tested 3 different kinds of sensing products. The first one is the magnetic flow switch, which has a whip switch on top. But under the experience, I found that when the gas flow under the small flame condition, the force is not strong enough to overcome the repulsive force between the magnet. So the whip switch cannot be connected and cannot give us output signal. Therefore, the magnetic flow switch is considered to be insensitive to use under the small flame, which is also bulky in size. Therefore, I look for a more sensitive product like the pressure sensor and to monitor the stove on-off status by the means of the pressure change in the gas system. However, even if the stove is not in use, there will be an unwanted pressure drop in the gas system whenever the water heater operates. That means the pressure sensor is sensitive, but also easily be distracted by other gas appliances, which seems to not reliable to use. And fortunately, I was inspired by a mass flow gas meter, which embeds a MEMS flow sensor inside. And the MEMS flow sensor is compact in size and is very sensitive to gas flow. It consists of 2 thermal piles and a heater in between. So whenever there is gas flowing above the sensor surface, it will create an uneven heat distribution between the two thermal piles, and by the magnitude, we can determine the flow rate as well as the flow direction. And therefore, I come up with the idea to put the sensor in the valve to see whether it works in our situation. I've done a simulation focusing on minimum flame, which is only 0.25 kilowatt or 0.5 liter per minute at 1 kPa in terms of flow rate. And in the simulation, I found that the velocity above the sensor surface is 0, which you can see in this white region. That means the sensor actually senses nothing because there is no gas flowing above the sensor surface and no temperature difference set up between the two thermal piles. To tackle this problem, I've designed a bypass flow accessory to separate the gas into two paths. The main path ensures enough gas flow to support the appliance maximum rating, while the bypass increases the gas velocity by covering the sensor surface. So after inserting the bypass flow accessory, you can see there is an improvement in the gas velocity above the sensor. And this will favor to the thermal piles for generating the temperature difference and consequently improves the sensor's sensitivity for the minimum flame operation. And with this simulation backup, we finally adopt the use of MEMS flow sensor and finalize our product design. And in the camera, you can see this is how the product looks like. And in the slide, I point out the key components that I've mentioned in the beginning, which is a communication module at top, followed by a shut-off valve with a MEMS flow sensor embedded in the valve with a flow accessory to increase its sensitivity. And this is how we install the smart control device to an existing hot plate, which you can see it is a very flexible and easy retrofit by installing it in between the gas hole and the gas pipe. Another key point I would like to mention that we can also retain the original stove to use, which is a very environmentally friendly approach to upgrade our stove to a smart one to perform those smart safety features. And talking about the communication module, since we have developed the full platform for the smart hub, basically the smart control device will use the same Bluetooth module and connect itself to a gateway and pass the information to the user through the cloud. So the whole implementation process can be speed up. And about the power supply, since the smart control device is powered up by 5-volt DC, so if we have a socket nearby, we can use an adapter, for example, the iPhone charger adapter to power up the device. But in Hong Kong, due to the limited space, it is uncommon to have a socket nearby the gas appliances. So we can use a power bank that is originally designed for powering up the stove and share its power. And under estimation, we can see that the power bank can support the smart control device for up to 450 days, which is a very long-lasting operation time for user to use. And lastly, I would like to point out what are the key functions that the smart control device can perform to echo the needs of home safety. First of all, it's the remote monitoring functions which allow us to check the appliance real-time status on the application wherever we are. Status like the appliance idling, appliance using, and the appliance is turned off by the smart control device can also be shown on the application. And targeting to those forgetful users, and especially for elderly, we introduced the Leave Home Alert function. The prerequisite of using this function is to connect your mobile phone to your home Wi-Fi. And so whenever you leave your appliance unattended and leave home, you will lose your connection to your home Wi-Fi, and you will receive an instant pop-up message, remind and suggest you to back home and turn it off. And this function is not only useful for the elderly, but also for their family members to take care of their safety at any time. And even if the user is not able to back home immediately, we also provide the remote shut-off functions. And by pressing the buttons on the application, we can give an instruction to the smart control device to shut off its valve and eventually turn the stove off.
3 minutes remaining.
And to make it clear, I've prepared a demonstration video for you to have a full picture of the smart control device. And in the video, you can see I've turned on the stove. The MEMS flow sensor will detect the gas flow and send the signal to the user and shown on the application. Even if I turn it into different flame levels, the stove on status is remain on until I turn it off. What if I forgot to turn off the stove and go to somewhere else? So instead of using the control knob on the appliance, I can press the button on the app so that I can send the signal to the smart control device to shut off its valve and cut the gas supply to the stove, which you can see after I confirm there's no gas at the burner and the status update. When I come back, the first thing I need to do is to reset the knob because the gas is shut. And for this action, I can actually use the app again by pressing the button again. So the valve is resumed and the gas supply is resumed. So I can use the appliance again. And I hope this presentation is clear to you, and thank you for joining my presentation. Thank you very much.
Thank you for that, Dexter. It sounds like a great innovation. I'm sure the judges are going to have some good questions. So yeah, over to the judges. If you'd like to pose your questions for Dexter, please.
I'd like to give Lucy the first question this time, and then I'll come in next after that, if that's okay.
Thanks, Ben. Thanks, Dexter. That was absolutely fascinating for me. You did mention the transition. Will take sort of eight years. I think for me, is this proven and tested and being adopted and being used at this stage, or is it just a concept?
This is not a concept. You can see actually the product is readily available, but we haven't launched a product because there are some more reliability tests to do. And for the 8 years I was talking about, from transitioning the old stove to a new one, because Thailand Gas is a very good company and our product is in a very high standard. So if the user just buy a normal stove, it can use up to more than 10 years. So they may not willing to purchase a new smart hob. Instead, they would like to use the smart control device to experience those smart safety function and kind of experiencing it and familiarize it.
Thank you.
Excellent. Dexter, excellent presentation. A really good, innovative, safe product. Really enjoyed it. Thank you. My question for you is, I can see the functionality and great to see the physical product, and I can see how well it practically fits in. I suppose one of my key questions then is, from a point of view of encouraging adoption by the home users, how is it cost effective? Have we got is it a relatively what's the cost impact to the hob in terms of encouraging customers to take it up? Whereas if it was too expensive, then obviously people would be reluctant to adopt it.
Yes, compared to the cost, of the smart control device to the smart hob. Actually, smart hob, the original price for the manufacturing price of a smart hob is actually around $1,500 Hong Kong dollars, and this is the cost summary of the product cost of a smart control device, and in total is only 500. Because this is not the final price of the product, because we are facing about the MCU shortage, which are all experiencing it, and because we only order a few MEMS flow sensor to check its reliability. So the part cost is a bit expensive, but it is adjustable depending on the MOQ and also the soldering technology. But in total, it's only 500 cost for a smart control device, which is very comparable to the smart hub. So we believe by this very attractive price, the user are willing to kind of experiencing this smart function, and we believe because of the cost, they are happy to install one at their home. And for us, it's a great opportunity to promote our smart kitchen solution and make it more popularized.
Excellent answer again. Thanks, Dexter. Just for benefit of quick Google search tells us that's about £50 for those of us who are in the UK.
Thanks, Ben.
So,
yes, no, I was going to ask.
So special offer for you all.
Absolutely. Andy, over to you.
Dexter, just a quick question, and again, my compliments on the presentation and the project. I like the idea of forgetful elderly, maybe because I'm getting there a bit, but how is it common in Hong Kong for such people to have access to and use smartphones? So is it likely they will interact with the control devices? Is that something you've given any consideration to?
So in Hong Kong, actually, for younger people, everyone are holding their smartphone on hand because they are busy with their friends or their lovers.
Yeah.
But for elderly, it may be one of the issues that they are not very familiar with the smartphone. That's why this product is not only available to the elderly, but also for their family members. And like what I mentioned, we have the function called the leave phone alert message, which is designed for their family members, also for their family members. So even if the elderly doesn't have a smartphone, that doesn't have monitoring their appliance, and when they leave home, their relative members can see they leave home and forgotten to turn off the stove, and so the members can help it to turn it off. So which is a great feature to those elderly, even though they are not familiar with the smartphone.
Okay, thank you very much.
And thank you, judges. Thank you, Dexter. That is exactly on the 5-minute mark. So that was excellent. Thank you.
Thank you.
Right. Well, thank you very much, Dexter. I'll introduce our fourth finalist, this time from the London Southern and Eastern section, Daniel Mee. Daniel Mee is from Cadent, and his presentation is titled Reduced Depth of Cover in Gas Distribution Assets. So Daniel, over to you.
Okay, I'll just share my screen.
Oh, I'll just say before you start, Daniel, sorry, it's excellent to see all the questions coming in the chat pane. If you chaps who have been before want to have a peruse through and see if there's any questions you can answer whilst Dan's doing his presentation, that'd be excellent. Sorry about that, Dan. Over to you.
Okay, can you see the screen?
Yeah, can do.
Okay, that's great. So, good morning, everyone, and thanks for the introduction, George. As George mentioned, I'm Daniel Mee, a senior integrity engineer at Cadent, and today I'm going to be talking about reduced depth of cover gas distribution assets, and in particular, those operating at medium pressure across agricultural land. So just a bit of background on myself. I joined the industry and at the time National Grid 10 years ago, straight from school as a trainee, and I now work within Cadent in the central 2 bar and below engineering team, setting the engineering framework for the organisation. And one aspect of the framework that I've developed is the engineering management procedure for 2 bar and below reduced depth of cover mains. The piece of work that I'm going to run through today is the justification piece that I've developed to underpin the reactive approach to the management of these assets in the form of a quantitative risk assessment. And throughout the presentation, I'll probably refer to this as QRA. And the QRA is based on individual risk that I have developed from first principles, and I've actually utilised this topic to pursue the technical report option in order to achieve incorporated engineer status with IGEM. So a bit of background wise at an issue. We have around 15,000 kilometres of medium pressure pipelines, some of which is located outside a public highway and at real risk of damage by private landowners, and especially when operating at reduced depths. So in October 2015, around 1,300 homes in Laceby were left without gas after a private landowner struck a 4-inch spun iron medium pressure gas pipeline that was laid in the 1950s across agricultural land. And the 4-inch was a single spur to the pressure reduction installation in the village of Laceby, where the gas is regulated down to low pressure. And the pipe, where it was damaged, was operating at depth of between 400 and 800 mil deep. So just a bit of research and the causal factors into why a pipeline is operating at reduced depth of cover across such land. And taking reference from the UK Onshore Pipeline Association, UCOPA, Good Practice Guide, some of the points are referenced in there. So we have landowner intervention through levelling or land use over time. We have natural erosion over time due to ground or weather conditions. We have the ground conditions in respect of the historic lay methods and the equipment available at the time in these remote locations. And the one I want to focus on for this piece of work is pipelines that were laid to historical construction standards. So after spending an afternoon in the library at IGEM House, what I've pulled together and showing on the screen right now is essentially a historic timeline for construction standards for medium pressure pipelines. And as you can see, the first standard was brought in 1956, and up until 1977, there was no depth of cover requirement in respect of open fields and agricultural land, and there was no reference to it. So it had been down to the local teams and engineers at the time to determine the appropriate depth to lay the asset at. And what I've found that some of the figures on the table, such as 2 foot, 2'6", and 1'6", are often quoted in easement documentation from historic pipelines. So it therefore does loosely align. So what I want to try and move away from is that anything that's less than today's standard of 1.1 metres be in reduced depth of cover, because the likelihood is that it was laid to the available industry standard at the time, and it was the appropriate depth, considering the land use, the equipment, and all the information available at the time. So the question naturally comes, given this knowledge, is the reactive identification approach that we take enough? And if we reference in respect of the pipeline safety regulations, regulation 16, whereby operators such as ourselves are required to ensure that persons are aware of the existence and whereabouts of pipelines. Now, clearly, where that risk is posed to buried pipelines operating at a shallower depth, this is even more important. So on the screen is a breakdown of the medium pressure network operated by Cadent, broken down by material type and categorised in date order against the IGEM industry standards referred to previously. And what you can see is the column which is titled agricultural length in kilometres. And this is the length of pipeline running through agricultural land. And in order to get these figures, I've undertaken a spatial query on our mapping software to identify where our medium pressure network intersects with agricultural land as defined in the Ordnance Survey master mapping data. And from our tracker and the ones that we're reactively working on, we're able to identify that all of those that we are working on and managing are associated with networks that were constructed prior to 1977. So I want to focus on assets installed prior to this date. And as you can see here, I've highlighted those assets. So carrying out this analysis allows me to see that of the total length of 15,080 kilometres, 1,246 kilometres runs through agricultural land, and 431 kilometres was laid prior to the introduction of the consideration for an increased depth. So we can therefore assume that assets laid before 1977 could be considered reduced depth if they're compared to today's 1.1 metre requirement. And the question is, how much of that is at risk of damage from normal agricultural activity, and in particular, less than 600 mil? So as I mentioned earlier about our reactive identification methods following notification, I've initiated the reactive survey as part of that management process. And following notification, we've surveyed around 1% of our total length of medium pressure pipe running through agricultural land. And then from these reactive surveys that we've done, we've identified around 41% of those are operating at a depth that we consider to be high risk, which is the less than 600 mil. And whilst the 1% survey sample size isn't statistically significant, we can still draw some conclusions from the available data. And similarly, not all land that Ordnance Survey define as agricultural is used as arable land. Some of it's used for grazing, pasture, and a variety of other types. So in the quantified risk assessment that I developed, I built this in using data that's available from the Department for Environment, Food and Rural Affairs, which is DEFRA. So extrapolating this to the total length of pipe that is laid in agricultural land pre-1977, it indicates that there could be 179 kilometres of pipe operating at a depth of cover less than 600 mil, meaning it's a foreseeable risk that we need to consider. So in consideration of this risk, and in order to demonstrate that our reactive approach goes far enough, I've developed a quantified risk assessment only to consider and establish the level of individual risk. So the definition of individual risk is taken from the IGEM standard G7 that's on the screen, but essentially it's the risk that's posed to a person in the vicinity . Sorry, I just lost signal there. Can you still hear me?
Yes, you're back now, Dan.
Sorry. Multiplied by the probability of casualty and the probability of exposure. So whilst a loss of supply is a serious incident, for the purpose of this QRA, I've considered the impact of risk to people, taking the hazardous event as the ignition of escaping gas caused by striking a reduced depth of cover asset, causing the pipe to fail. Now, clearly this could lead to a fatality if all the holes in the Swiss cheese model align. Now, for the frequency of incident, as we haven't had a hazardous event of this nature, we can only utilise the Laceby incident as a reference point, as it could have been foreseeable that that could have escalated into the hazardous event referred to. Now, the probability of casualty that I've calculated is based upon the probability that a pipe will leak given that it is struck, the probability that escaping gas will ignite, and the probability that there will be a casualty upon the ignition of gas. The probability of exposure is based upon the probability of subsoiling, the probability that the pipe is shallow, and the frequency of the subsoiling. And by subsoiling in this context, I'm referring to agricultural operations that break ground in order for arable production of crop. So in order to calculate the individual risk as part of this QRA, I've had to put numerical values to the three elements of the calculations using the data that I've extracted from the systems and making engineering judgment in respect to probabilities based on the available information in the trackers and literature that's out there. And the numerical outcome of these database calculations gives an outcome of 1.48 times 10 to the minus 5, which places the risk above the broadly acceptable region and into the tolerable if alert region. It's worth noting that whilst the conservatism is built into the QRA, because it places the outcome in this classification, it means that as Cadent we have to apply relevant good practice, which we do through our reactive management approach, and consider the implementation of risk reduction measures. Now, the risk reduction measure that could be implemented would be a one-off survey of all assets laid pre-1977, implementing management processes across those that are less than 600 mil. Now, principally, the reason this hasn't been implemented by Cadent is because I've undertaken a cost-benefit assessment to determine that the cost of implementing the measure is grossly disproportionate to the benefit gained relative to the risk posed by the scenario based on historic incidents. So to summarise, on the back of the Laceby incident, we know that there is a risk posed to assets operating at reduced depth of cover, and our current approach to reactively manage these assets is an absolute requirement. On the research I've done, and my knowledge of working on live cases in the network, there's a clear link between the historic construction standards and pipes laid before 1977 where these risks are present. The analysis I've undertaken as part of this piece of work, in order to underpin our current approach, demonstrates that the individual risk posed is tolerable if alert. And following the outcome, as previously mentioned, the cost-benefit assessment means that it is not justifiable to implement further risk reduction measures across this asset stock. However, whilst it's not an appropriate action to blanket survey all of these installations, in respect of our net zero proposals and the desire to reconfigure, replace and repurpose the network to transport hydrogen, one thing that this work has driven within Cadent is targeted surveying of these pipelines before considering them for repurposing activities. And also working with our design engineers within the networks to see if we can reconfigure the network in order to remove the risks from the gas supply arrangements. So look at whether we can configure the gas network to supply gas in different ways, removing the need for these cross-agricultural land pipelines. Then on a personal level, it's allowed me to gain a greater understanding of historic standards, where requirements come from and how and why they change over time. And it's also allowed me to gain a deeper understanding of QRA development in terms of the input parameters and how conservatisms and accurate data have a large impact on the outcome. So thank you for listening, and I welcome any questions that you may have.
Thanks for that, Daniel. Yeah, it's a fascinating snapshot of how standards have changed over time. So I thought it was really interesting. Quickly, before I hand over to the judges for their questions, I'd just like to point out, I've noticed a few more people joining the call, which is excellent. Welcome to this morning's session. If you do have any questions for Daniel or any of the other finalists, please note them down in the chat. If we've got time within the 5-minute window for Q&A, I'll get around to them and ask Daniel on your behalf. And if not, then hopefully Dan wouldn't mind dropping into the chat after his presentation to answer a few of them. Yeah, super. Right, over to yourselves, Ben, and the rest of the judges.
Excellent. I'll take the first question this time. So firstly, Daniel, many thanks for the presentation. Excellent overview. And like George, I confess it was a bit of an eye opener to me to see some of the evolution in the standards, and that was very well clarified. So I suppose it's a relatively simple question, actually, Daniel. I think showing the kind of breadth and the combination of research and development and how you've carried that through during this whole process and project, what's probably been the greatest challenge for you in terms of, along that particular journey?
So the biggest challenge for me as part of this was, there was a couple. So one of the big challenges I had was extracting the data out of the systems. So pulling data from our system, modelling it against the Ordnance Survey data, understanding the interaction between that and then the DEFRA information. So trying to draw some conclusions from a mass amount of data set was a real challenge. And then also from a quantified risk assessment perspective, although I work with them on a regular basis as part of my role, I've never had the opportunity to develop one from first principles. So taking that from scratch and building it into this sort of numerical model that's given me an outcome was a real challenge. So I went on sort of webinars, training courses to try and understand the principles of it before starting to then develop the probabilities, and understanding that interaction between a small change in one of the probabilities has a massive impact on the outcome of the QRA. So it's getting those engineering judgments that I've made as appropriate as they can be. So that was the biggest challenge for me.
Excellent, thank you. Andy, I'll hand over to you.
Yeah, thanks, Daniel, and congratulations on the presentation. Two questions on related to the QRA, but first, has your work been shared with the HSE to any extent?
So at this moment, it's not been shared with the HSE. We've only I've only recently, earlier this year, sort of finished it as part of my technical report, and within Cadent, we're sort of taking it through our own governance processes through our Safety and Engineering Committee to get it sort of signed off internally, with a view that this sort of sits underneath our management procedure and underpins our decision making and approach, so that if required or as a proactive measure with the HSE, it's there and it's able to be evidenced. And one of the key things for this personally is that as we gain and gather more information and that could change the probabilities, we don't just leave it as a static QRA. We need to continually refine and refresh the information so that it is relevant.
Okay, thanks. And just specifically to the QRA, you mentioned in terms of likelihood of incident that Laceby was your only reference point effective there, but surely there must be other information related to strikes and damage that doesn't lead to leakage that you could build into that.
Yeah, so one of the difficulties with that is, so we have a massive data in the system on asset damages.
Yeah.
Now that can range from a fence post being put in on a pipeline that's a reasonable depth, or it could range from a strike from a plough being pulled under normal agricultural. So at the minute, the issue that I've got in factoring in that data is there isn't the level of granularity in the system to be able to determine the difference. So when we start looking at cases where we have a reduced depth of cover asset, one of the first things that I do is pull out the pipeline data and the leakage data to understand the leakage causes that are on that section of pipeline, and then determine whether any of those could be linked to the pipe being shallow, such as fractures, interference damages, things like that. Things such as joint leakage, we know as an industry that joints just leak regardless. So it's really understanding that data that's the challenge at the minute, because there isn't the level of detail in there.
Okay, thanks. Thanks very much.
Thanks, Dan. I think the questions I've had, you've already sort of answered, really. I think it was a fantastic presentation, and I think your personal involvement is very clear around the whole project, and thanks for sharing that with us, and also the lessons learned, what you've personally learnt throughout the project. I guess for me, it was around what support you've had, I guess, with you've identified some of the challenges you've had around the data, and one of my questions was around sharing that information, and you obviously you're not quite there yet, but internally, what stakeholders and externally, what stakeholders have you had to engage with and have conversations with?
Yeah, so externally.
Sorry to interrupt there. We've just reached the 5-minute mark for your Q&A.
Oh, no.
I'd invite you to still put, it was an excellent question. I don't want to stop the answer. So Dan, if you want to put your answer in the chat for us all to read in a moment, that'd be much appreciated. But yeah, unfortunately, we're gonna keep this going and progress onto our next presentation. But yes, thank you very much, Daniel. And thank you, judges, again for another round of questions. So our fifth and final presentation from this morning's session is Bernadette Nugent from Kier, who is our Irish section winner, semi-final winner. The title of Bernadette's presentation is Gas to the West, Coal Island. So I'll hand over to Bernadette when you are ready.
Thank you. Excellent. Now, is the screen showing okay, George?
It is, yes.
Perfect. Okay, so hello, everybody. First, I'm going to begin by introducing myself and giving you all a bit of a background of my time within Kier. So as you all know, my name is Bernadette Nugent. I started with Kier in August 2017 within the planning department on the Firmus Energy contract. I then moved down to the Gas to the West project in May 2018 after Kier was successful in their tender with SGN. So I initially started in this contract within the record keeping department, and this role included completing as-laid sketches of newly installed gas mains, checking weld records, and also assisting the lead engineer when it came to the actual testing and commissioning of the gas pipeline. I then progressed into my current role, which is the SHE advisor, in January 2019. So I want to move on and show you a short video with the aim of showing you who Kier are and what we do on a day-to-day basis on the Gas to the West project. So, as you could see from the video, we are the main contractor for the Gas to the West project, with our client being SGN Natural Gas. So on the daily, we complete domestic connections to properties and also connections to larger industrial and commercial properties as well. So we install gas mains primarily through open cut techniques and horizontal directional drilling. However, the video I've just shown you is not 100% accurate. It did document Coal Island as being one of the towns that we were due to complete in 2020. That was not the case. Coal Island posed a problem for us, and that problem was Crana Bridge. So the gas main that Kier installed in 2020 came down Crana Bridge Road and Lockview Road, as shown by the yellow lines there on the screen. Ideally, these two sections of mains could have been joined by installing a shorter section of gas pipe over the Ballinakilly Road over Crana Bridge, as shown by the orange dotted line. This was not the case. The selected route was constrained by wayleave requirements, as the land will be subject to development as part of road network improvements and a new bridge crossing within the next number of years. So a complete redesign was then required, where the only option then was to cross the River Torrent, as shown on map 2. So with this project, I have learned a great deal. I have had to think outside of our normal day-to-day working techniques and employ a method that we have never implemented before on the Gas to the West project. I had to ensure that the works were planned and carried out safely. I have learned that things do not always go to plan and things can change very quickly. It was my responsibility to address those changes on site and ensure the project kept on track. So my passion for good communication and projects has been reinforced. As I said, things did change and I had to make sure the communication was kept to the forefront at all times. So, as I mentioned earlier, we are a contractor who specialises in open cut techniques and horizontal techniques, horizontal drilling directional techniques. With this project, an open cut method was not feasible, just given the channel profile at the crossing point of the river. There were mature trees in the area as well, and there's also a risk of pollution to the river. Horizontal directional drilling using drilling fluid had a severe risk of pollution to the water courses, as the drill pits would have been in close proximity to the riverbanks. It would have introduced a high risk of frack out that may have been capable of affecting the fisheries and downstream sites. So I had to research a feasible way to complete the crossing, and a pipe ramming method was the option chosen to install the 250mm gas main across the river. So for pipe ramming is a method of trenchless technology, whereby a steel duct is installed under a particular obstacle. So this obstacle may be a road, a railway, a canal, and in this case it was a river, the River Torrent. So how it works on the principle of displacement. It causes little to no ground slump, which made it ideal for the River Torrent crossing, as this was an area where ground loss may be expected. For the crossing itself, 18 metres of a welded steel sleeve, which was 323mm in diameter, was needed for the installation of our 250mm gas main. So 2 pits had to be excavated, one at either side of the crossing, both which required temporary works design, which I will discuss later in the presentation. So once the launch pit had been excavated, the pipe ramming rig had to be installed. So this included a lifting operation, which I had to plan and ensure on site that it was carried out in a safe and controlled manner. So a frame was placed into the base of the pit and the first length of the pipe was fitted. A cutting shoe was then welded onto the front end of the pipe, and what this cutting shoe actually does, it has a hardened edge which it helps to protect the end of the pipe, and it also breaks any large cobbles or boulders encountered in the path. The frame then was adjusted to the level that was required for the crossing, and next the hammer was fitted and the compressor hose was strapped into place. And you can see just in the middle photo there, a photo of that. The hammer was then connected to the compressor and driving commenced on site. So the first length of pipe was driven in quite slowly. And the reason being, it was just to establish the pipe in the ground and check the ground conditions that we were coming across. So once the first section of pipe was installed, the next length of pipe was then lifted into place and it was welded onto the end of the first length of pipe. Driving was then able to progress on site around 6 meters an hour, just depending on ground conditions. So this process was repeated until the destination across the River Torrent was reached. So once the steel pipe was successfully across, the next step was to actually remove the material from inside the pipe. This was achieved by pressurizing the end of the pipe with air, and it enabled the soil inside the pipe to be removed via the reception pit at the other side of the river. So in the next slide, I'm going to show you some footage of the actual site setup. In the video, you will see a complete overview of the works location. You will see the launch pit with the temporary works setup, and you will also see some environmental controls as well. Now, once the method was chosen, I then had to think about access to the excavation. So I identified specialist temporary works were required. So for background, basically what temporary works is an engineered solution, and that is needed to enable permanent works to be built. So for example, scaffolding would be temporary works, props, hardened, and in this case, it was excavation support. So with this project, 2 pits were required to accommodate the crossing. A launch pit was required, which what you can see in the middle photo there. It was 12 meters long, 8 meters wide, and 3.3 meters deep. This was needed to allow for the specialized pipe ramming equipment to be installed. So for the temporary works design, I had to work closely with an external temporary works designer to ensure that I implemented the correct method for the safety of all those involved in the works. Initially, a full wall of 20 steel sheet piles were recommended based on the borehole, which was completed on the reception pit side of the river crossing. However, upon initial installation of the first sheet pile, it was evident the soil conditions were quite different, and pile refusal was met on the piles just due to the hard nature of the ground. So I then had to source a specialist excavator, which had an attachment for side grip pile driving. I then had to amend the temporary works design based on what conditions we were finding out on site and send for approval before we could actually then proceed with the installation. So based on this, the design was amended to 16 sheet piles on a hit and miss capacity. The reception pit itself was slightly different. It was smaller, and it only required a trench box, which was a generic design. But again, on site, I had to ensure the correct installation of this equipment and access in and out of the excavation as well.
3 minutes remaining.
Thank you. The method I've chosen for the installation was primarily for environmental reasons. Pipe ramming is a method that requires a lot of excavation to get down to the required depth of the crossing. So construction of the launch pit required a ground reduction with the removal of approximately 100 metre cubed material that had to be stockpiled, was to be used for backfill and later on. I had to ensure that a spoil was excavated and stored in a safe manner on site to ensure there was zero risk of pollution to the river torrent. I then had to look at the possibility of groundwater. I had to ensure that any groundwater that may have entered the excavation was pumped out and controlled by a settlement pond. And I had to check the weather each day. It was my job then to cease the project itself if the weather was forecast to be poor. So as with any job we undertake within Kier, I needed to ensure that we complied with the 5C basics. And this was to make sure that everybody on site had an adequate induction, which covered our requirements as the main contractor and also our client's requirements. I then proceeded by ensuring the team were briefed on the risk assessments for each task and where they could access that information. I had to complete a safe system for the work, which detailed each task right from the beginning to end. And I had to ensure that the daily risk assessment was complete and any on-site changes were documented accordingly. And finally, I had to ensure competence for all those on site. It is by starting off with the 5C basics that I was able to ensure this project's chances of an accident or injury occurring on site were significantly reduced. So in summary, this project does have a relevance to the gas industry. It has allowed our Northern Ireland network to be expanded. In total, there are now 5 kilometres of spine gas mains installed in Clyland and 2 kilometres of infill gas mains laid. There's also 3.5 kilometres planned for further gas infill works. And on the 15th of October this year, Clyland was successfully commissioned. It is down to the planning, design and smooth running of the Torrent River Crossing project that has allowed this to happen. Next year, there are also further infill works planned for Clyland to expand the network. Currently, there are nearly 500 properties passed. By the end of 2022, there will be nearly 1,300 properties passed. And by the end of 2028, there will nearly be 2.5 properties passed in Clyland. This project does allow the residents of Clyland to reap the associated rewards and change over to natural gas. As you can see there in the middle picture, it was as if we were never there. That is the final how we left the site then. And again, natural gas will provide the security to those residents in Clyland, and there will be no more worrying about running out of fuel or forgetting to order fuel. So I want to thank you all for your time today, and I welcome any questions that you may have. Thank you.
Excellent. Thank you for that, Bernadette. Perfect timing. Judges, over to yourselves with any questions.
I'd like to give Andy the first question this time, if that's okay.
Okay, thanks. Thanks, Bernadette. Excellent presentation, and enjoyed the videos. You mentioned early on that communication was a big learning point for you. So, what was your interaction with the client directly when all these problems were cropping up and you were solving them?
With the client, it's mainly our main contractor on site. I'll be working very closely with the foreman on site, just to make sure that any changes I would then have to, especially with the temporary works design, it was my responsibility then to go back to our temporary works designer. So I had to be on site daily for that, and just to make sure that, you know, we kept in communication. It was a lot of to and fro and emails back, pre-site meetings, on-site meetings. And basically that is why it ran so smoothly. Now, we did have a few issues, but again, that was for me being on site and having that good communication with our main contractor on site as well.
Okay, I was thinking also of SGN in that question.
Yeah, for SGN, now it was SGN were involved initially in the tender process and who we were choosing to complete the works. And again, on-site visits as well. So us as the main contractor, we have the main responsibility for the on-site works, and we are responsible for managing those works and making sure the job progresses. So it is down to us as the main contractor to make sure that we are choosing the right option then.
Okay, thanks. Thanks, Bernadette.
Lucy, would you like to go next?
Thanks, Bernadette.
Thank you.
And like Andy, I enjoyed the video. It really brought it to light.
Thank you. I hope it worked okay, because it was freezing on my screen. So I was thinking, but that's just technology. That's what happens.
Yeah, no, it was really good to see the scale of, you know, it was really visual, and I'm a little bit in awe, Bernadette, of you being able to kind of pull that off. I mean, one question for me really, how long did it take longer than how long did that work take? From
No,
kind
it
of
actually
start?
it went really smoothly. As I said, there was a lot of work before we actually got on site. So there was works in advance of a year doing pre-site checkups just to see the flow of the water and what way that those fields actually dealt with in different weather conditions. There was a lot of pre-planning in terms of what was the correct time of year in order to do that project. In terms of the project itself, we were on site for the guts of 2 weeks for that actual project. So there was a lot in it and it did run very smoothly, but it is down to, as I say, we have a very good team here and good support. So that's what it really came down to in the end.
Thank you. That's it for me.
Thank you.
Thanks, Lucy. Yeah, so question for me, you highlighted on a couple of points where you had a decision to be made, where there was different factors, to be considered. And I just wondered, what kind of process did you follow when trying to make that decision? Was it weighting factors applied in terms of cost v time v public v, or was there sort of external factors that made it very much more a pass fail sort of type matters that they just weren't on the table right from the off because of a way leave issue or whatever the issue would be? I'm just understanding I just want to understand the selection process a little bit more.
Yeah, so for the actual for the decision to be made for it to be a pipe ramming method, as I said, open cut wasn't feasible, just given the channel profile, and there were mature trees along the whole length of that riverbed, so that wasn't an option for us to go down that route. And then horizontal directional drilling, just due to the size of the pipe, 250 mil pipe, may have needed drilling fluid. So again, risk of frack out to the river. So that wasn't an option. So it was very much consulting with an environmental consultant to see what our best option would be there, and having those meetings and having those discussions. And it is about choosing the correct method. In terms of when we were on site and the decisions that had been made, I suppose whenever we were on site, we did have an excavator which had an attachment to actually install the sheet piles. That didn't work for us due to the hard nature of the ground. So it was very much, we were on site, we were there ready to go. So we had to go for the next option, which may have been more expensive to get in specialized trench, a side grip pile driver excavator. It's more expensive, of course, but again, we're on site to do a job and that job has to be done. So even though it may be more expensive, we had to wait in order for that to get to site. These decisions just had to be made. So thankfully it all went well. But again, it is down to good communication and contacts and teamwork.
Okay, thank you very much, Bernadette.
Thank you.
Back to yourself, George.
Right, yeah, thank you very much, judges, and thank you, Bernadette. So that concludes our 5 presentations for this morning's session. So all that leaves me to say is thank you very much to Chikan, Kyle, Dexter, Daniel and Bernadette, and for all of those of you who have joined the call this morning. So what happens next? We will be having the second session that begins at 11:15, and for the next 5 finalists, the short break after that, and then the awards at the end. Do remember that it's a separate link for the second session. Don't try and join this one because you'll find you're in a group on your own and doing your own presentation. So yeah, I look forward to seeing you all at 11:15 in the second session. Bye for now.